Kia ora Year 10. These are the last few questions from the JAF practice for algebra, and these are the extended abstract questions. So there are only 3 of them, but they're pretty full on compared to the rest of the practice test. We're going to start with this first one, which is a factorising one, and it's testing how well you understand both the idea of factorising and what powers are in algebra. So let's start. I'm not going to start with that example. I'm going to start with an example with numbers in it. Suppose that I had x to the power of 5 plus x to the power of 7, and I wanted to factorise it. So what I would be saying here is, what is the highest common factor of these two terms? Now there are no coefficients to deal with, but this one has got x to the power of 5, and this has got x to the power of 7. So the highest common factor of those two terms is x to the power of 5. X to the power of 5 times what will give me x to the power of 5? Well, it's just 1. Now, x to the power of 5 times what will give me x to the power of 7? Well, I know that when I've got the same base, I just add the powers, right? So we get this, 1 plus x squared. So if you understand that idea well, then this question is not bad at all. But if you don't understand this idea well, what you've got to do is go all the way back to basics about what it means to, why can we add the powers when we've got the same base. And I've gone through a couple of examples of that in the unistructural videos for the practice JAF. So let's now look at this one here. We've got x to the power of n plus 3 plus x to the power of n minus 1. So the brackets aren't really doing anything here, we can just get rid of those. So think about what we did when we had x to the power of 5 plus x to the power of 7. The highest common factor was the lower of these two numbers. So which number is lower here? Is it n plus 3 or is it n minus 1? Well, it's n minus 1. So we have x to the power of n minus 1 times what? We have to ask, what do I have to times this by to get back to this? So think about your number line. Here's n minus 1. Here's n plus 3. How many hops have I got? Well, I've got 1 hop to n, 1 hop to n plus 1, 1 hop to n plus 2, and 1 hop to n plus 3. So if I add on 4 to that, I'll get to n plus 3. So this will be x to the power of 4. Plus, what times this will give me this? It's just 1. Okay, so that's the first question done. Let's have a look at the second one. So the second question, number 28, is conceptually, I think, pretty straightforward. It's just you've got to do a bit of work and remember how we work with fractions as well as how we work with BEDMAS. So I'm going to start by copying the question out down here. I've got 3x squared cubed over 4b squared plus 5x over 4b squared divided by 10xy over 2x squared. So one thing we want to really avoid with questions like this is running arithmetic. The first thing I notice is that I've got this plus all of this. I need to deal with these two things separately. The first thing I'll do here is to sort out what I've got in the brackets. So 3 cubed is 27. I get 27x to the power of 6 over 4b squared. Plus, now I'm going to deal with this. It's going to take a few steps. When I divide by a fraction, I'm multiplying by the reciprocal. So we'll start out by simply taking the reciprocal of that second term in here. So it's not that, it's times 10. 10xy should be now in the denominator, and 2x squared here. So I need to do this plus all of this. So notice that I'm doing one equal sign per line, no running arithmetic, and no false statements. It's just like when we did our number work at the start of the year. We have to make sure that whatever's on the two sides of the equal sign has got to be the same thing. It doesn't mean this is the answer. Okay, so multiplying the denominator here, we get 40b squared xy. Multiplying the numerators gives me 10x cubed. Right, now the next thing I have to do is to find a common denominator. So I've got this and I've got this. If I times this by 10xy, I have a common denominator. So my common denominator is going to be 40b squared xy. So this needs multiplying by the same thing. So this is just equivalent fractions. We get 270 x, what have we got? Is that right? 270x to the power of 7y plus 10x cubed. Now I'm just checking I haven't mucked anything up here. I know someone's going to leave me a message in the comments if I have, but so please do. Okay, so we're just checking. A common denominator here is 40b squared xy. Yep, that looks good. Okay, and I think we have finished. Have I made a mistake somewhere? I've got a cube somehow. How have I got a cube coming in? Oh no, I think that's good. Right, okay, on to the last question. Sorry about the blathering on. It's been a very, very long final week of working from home. Right, this looks horrible. Absolutely horrible. It's got lots of square roots, so we've got to do lots of nice cleaning up. And we have to find the term q. So let's just sort it out first. Let's do some cleanup before we look at what we really have to do. I'm going to expand this, and I get 25x to the power of 4 times the square root of this thing. We've already done one of those in the relational video, so this is times 4x to the power of 32 divided by 12q is equal to x to the power of 5 over 6. On the left hand side we can simplify further. We've got 100x to the power of 36 divided by 12q is equal to x to the power of 5 over 6. So what we're trying to do here is to match up what q has to be to make those two things the same. Let's simplify the square root thing. We get 10x to the power of 18 over 12q is equal to x to the power of 5 over 6. There are several ways to go from here. Most people doing this would be doing it by solving the equation and making q the subject of the equation. And we do that a tiny bit in Year 9. That's how I'm going to do this question first. First we can simplify this. We've got 5 here and 6 here. So 5x to the power of 18 over 6q is equal to x to the power of 5 over 6. What do I need to have for this to match up? Well, I can multiply both sides through by 6. So now we've got 5x to the power of 18 divided by q is equal to x to the power of 5. I'm going to multiply both sides by q, and we'll have 5x to the power of 18 is equal to q times x to the power of 5. Lastly, to isolate q, I'm going to divide both sides by x to the power of 5. That gives me a final answer of 5x to the power of 13. So that's what q has to be. Now I've done that by rearranging and finding q like that. I'm going to go back a little way now and show you a slightly different way I can think about it. And I'm doing that partly because we haven't gone over solving equations in Year 10 much yet. It's in the current topic, not the last one. So the method that I just did might seem a bit funny. So let's look where we got to. We got 5x to the power of 18 over 6q is equal to x to the power of 5 divided by 6. So for q to make the two sides the same, we've got x to the power of 18 here, but we want to have x to the power of 5. So if I have this, let's just try it out. If we have x to the power of 13, We're getting pretty close, right? Because that's going to simplify to give me that. So if q is just x to the power of 13, I'm nearly there. But I've got this 5 in here. I've got a 5 here. I can undo having a 5 times in here by dividing by it. So let's try this instead. 5x to the power of 18 over 6 times 5x to the power of 13. What will that give me? Well, now I've got the 5's simplifying away, and I've got x to the power of 5 because of this divided by this over 6. So we've got there. Right? But I think most of you watching this probably want to do it by rearranging the equation and getting to q equals blah blah blah. But there's a couple of options. Okay, that's a very, very long answer to that last question. And I know some of you watching will still find this question really hard. So feel free, if you're in my class, to ask me for some more examples like this, or we can talk about how there are the two ways to do this question. Thanks for watching. That's all for today. And